Okay, a very warm good morning, all of you. Yesterday we are on the discussion of voltage control, the methods of voltage control by using transformers. So in that yesterday we were discussed about the tap changing transformers. So the tap changing transformers, so thereby depending upon the position, different position, we can control the voltage. If you want to control the reactive power, we have to control the voltage as well. So like that we can get the difference values by the LDC, this load drop component, and by using suitable adjustments of the tap we can inject the reactive power into our circuit. So by injecting the reactive power we can control the voltage as well. Okay, so that's about the tap changing transformer. And the next topic is booster transformers. So this is like this is also kind of a system, kind of a, what we can say, the transformers. So here we are using boosting the boosting the required amount of voltage. We have seen the converters, the buck converter and boost converters. Similarly, here also we are having the boost transformers and buck transformers. Okay, so it is necessary to increase or decrease the voltage at an intermediate point in a line rather than at the ends. So what that means, at the end means at the utility side or at the load side. So instead of using the voltage control or the improvement of voltage at the receiving ends, we can use the boost transformers in order to increase or decrease the voltage levels. So why we are interested in the intermediate transmission line? Because we have to keep concentrate on the minimization of transmission and distribution losses as well. So if you are using that boost transformers or a buck transformers at the intermediate of the line, we can minimize the losses, and also we can control. And also we can control the voltage signals. So controlling of the voltage signals is nothing but controlling of how much amount of voltage that we need to transfer, or how much amount of voltage that we need to minimize, or we need to control the flow of voltage. So like that it will be easy and it will be economical to operate if we are using different booster transformers at the intermediate point. Okay, so separate transformer is used to boost or buck voltage of main transformer. So similarly, the boost transformer or buck transformer, the construction wise it is same. The only difference is just like a step up or step down transformers. So similar to step up or step down transformers. So these transformers used to increase the voltage levels or decrease the voltage levels, and the construction wise and the working principle will be same, mutual flux inductance. Okay, and the same, everything is same, only thing is we are supplying or drawing the voltage from the system. Okay, so this is the buck transformer, or the bucking or boosting of voltage will be done by injecting the voltage in series with the line through a transformers. So these are similar to main transformers. So these from where we can inject the voltage. So injecting the voltage into our main transformers through the buck or boost transformers. So that will be done here. And one more thing is, booster transformer is fed from a regulating transformer from the tertiary ends. So the tertiary ends. So for that we have to look for different aspects. So these are our configurations. So these are our configurations of different booster transformers. So the first figure. So this is the figure showing the booster primary is fed from regulating transformers. So the regulating transformers. So this is our regulating transformers. So from this regulating transformer, we are boosting the primary side of the voltage, primary side of our booster transformers. So booster primary is fed from the regulating transformers. This is a one kind of transformer configuration that we use in our booster transformers. And this is another kind of transformer where the tertiary winding of the main transformer. So here these are the tertiary winding. So normal booster transformer is connected to tertiary winding of the main transformer. So normally transformer will be having primary and secondary. So along with that, if for the application of booster transformer, it is slightly modified and used one more winding that is called tertiary winding. So that this is the tertiary winding and tertiary winding of the main transformer. So this tertiary winding of the main transformer is connected with the booster transformer. This is connected with the booster transformer. So this is a one more kind of configuration. Okay. So booster transformer is fed from regulating transformer from the tertiary end, and booster primary is fed from the regulating transformers. So these are the two kind of transformers. Okay. And reverse switch reverses. So reverse switch reverses. So what that means? The reverse switch reverses. One reverse switch will be there. So the reverse switch reverses its operation. So that means the previous operation of the transformer. Okay, reverse switch reverses. If you are going to off the switch, reversing of off is on. So previously it is on. So if you want to reverse, that means off. Reversing of reverse is opposite of off, that is on. So like that, the reverse switch reverses the polarity of the injected voltage, and hence a boost is converted to buck. So if you want to convert the boost transformer, sometimes what happens, the transformer we are using as a booster transformer in order to inject the voltage into our main transformer. After that, because of some conditions, that is, the condition is nothing but, okay, the load is satisfied with the reactive power balance. Injecting of current is nothing but balance, injecting of reactive power. So after some duration, what happens? The load is satisfied with the reactive power. And sometimes if the load may be converted into capacity load. So what happens at that time? It may start, the load may starts generating the reactive power. So if the load is started to generating the reactive power, at that time what happens? We have to absorb that reactive power in order to balance the voltage. So at that time, if you want to balance the reactive power, we have to absorb the reactive power. Okay. So if you want to absorb that reactive power, you have to draw the current. So at that time, when you have to draw the current, you have to use buck transformer, which is stepping down. Buck is nothing but less amount compared to main transformer, main voltage. Okay. So if you want to convert the booster transformer into buck transformer, at that time you have to reverse the polarity of the switches. So at that time what happens? If you are by reversing the polarity, the injected voltage, and hence a boost is converted into a buck. Okay. So winding should not be open circuited. This should be saturate the core. So here you can observe. So these are our reverse switches. As I just told now, reverse switches. So these are the reverse switches. We need to concentrate about the polarity of these switches. So when we are using as a booster transformer, the polarity may be selected at position 1, and if you want to convert that into second, the buck transformer, it may be converted into second polarity, or vice versa. So this polarity may be depends upon the voltage at the primary end, voltage at the regulating transformer, and at the booster transformer. So depending upon the requirement of voltage, the polarity will be selected. So if one polarity will be selected as a booster transformer, then another will be converted into buck. The same thing is in both the configurations. Okay. So here the first configuration is the primary of the booster transformer is connected to regulating transformers, and in the second configuration, the primary of the booster transformer is connected to tertiary winding of the main transformer. Okay. So these are the two different configurations, and here, as I mentioned, the reverse switch reverses the polarity of the injected voltage. That means we are converting the booster transformer into buck transformer. Okay. And main thing is the power rating of the buck or boost transformer. So if you are injecting the voltage into the main transformer, it acts like a booster transformer. And if you are injecting the current in the less amount compared to the main transformer, at that time the polarity of the booster transformer will be reverses, and that is changed into buck transformer. So the rating of this buck transformer or boot transformer is very small when compared to main transformer. Okay, very negligible rating, very small rating compared to main transformer. So this will be depends upon mainly the power associated with the injected voltage. How much amount of voltage that you are going to inject, how much amount of voltage that you are going to inject through the booster transformer. So that will be decided based upon the power rating of booster transformer as well as the corresponding transformers, whether maybe it is regulating transformers or at our main transformers. And the next thing is the winding. The winding should not be open circuited at the winding should not be open circuited, whether maybe it is booster transformers or at the regulating transformers or at the main transformers. So here the winding should not be open circuited because the core may be saturated, the core of the transformers. So if you are not using the windings, what happens? If you are not going to connect, ಏನಾಯ್ತು ಅಂತಂದ್ರೆ ನೀವು ಓಪನ್ ಸರ್ಕ್ಯೂಟೆಡ್ ಬಿಡಬಾರ್ದು. So you should not be leave open circuited. If you leave open circuited, what happens? The main functioning of transformer is collapses. Main function is nothing but we have to keep the saturation of the core. So if you are not going to keep the saturation of the core, at that time you are unable to receive or send any kind of voltage levels. So for that purpose, you have to close the windings of either circuits, either transformers, whether maybe booster or other transformers. Okay. And also one more thing is the buck transformer or boost transformer is an economical solution to adjust the line voltages. So line voltages, we need to adjust the line voltages. So for that purpose only we are using the transformers in order to adjust the line voltages slightly, not very high much, very much high. Only if you want to use the booster transformers or tap transformers at the very sensitive equipments. So we need to concentrate the sensitive voltage signals as well. So at that time we need to inject or balance the line voltages slightly above or below the nominal value of our voltage levels. Okay. And the main thing is these kind of transformers mainly will be used in our distribution feeders. So distribution feeders, there we can witness these kind of transformers. So the operation will be like this. So these are our lines. So this is our line. Okay. So which is normally placed the transformers on the line. So these are we can say the R1 and R2 are different our relays. So these are our relays. So depending upon the required amount of voltage levels, we can open or close these relays. Okay. So this is a kind of our transformer winding. So these are our transformer winding. We are placing these windings in along with the line. So if you are interested to insert or one line, one terminal of the winding, so one booster transformer winding, at that time so R1 may be opened. So R1 might be opened. At that time R2 should be closed. And similarly, if you are interested to place the booster transformer windings, at that time R2 should be closed and R1 should be open. So these are our different relays. So these acts like a switches to place the windings of our booster transformers along with the line voltages, along with the line, in order to grasp the voltages. Okay, so the conclusion is here: the booster transformer will be used, booster or buck transformers anywhere. So these will be used in order to inject the voltages to the line, inject the small nominal value of voltages into the line. Either maybe you can inject above the nominal voltage levels or below the nominal voltages by using our different switches, reverse switches. So these are our tappers. So which based upon the required amount of required voltage levels, we can tap the secondary of our regulating transformers. So this is our primary side of our booster transformers. This is the secondary of the booster transformers. So normally the secondary will be connected along the line. So this is our secondary of the booster transformers connected along the line. Okay. And that's all about booster transformers. The next thing is phase shifting transformers. Here the concept is simple. The phase shifting transformers are used when there is a need to control the active power flow. So if you are interested to control the active power, at that time we can use phase shifting transformers, and the active power flow of the along the line and the reactive power flow along the line will be given by using these two equations. So these are our basic general equations, for active power and reactive power. So P12. So here P12 means the power is flowing from one area to another area. Okay, so one end the bus 1 to bus 2, you can say bus 1 to bus 2. Okay, and will be given by V1 V2 divided by X12. So V1 is the voltage at the sending end, you can say, and V2 is the voltage at the receiving end, or else V1 is the voltage at bus 1 and V2 is the voltage at bus 2, and X12 is the our reactive impedance of the transmission line, the transmission line through which the voltage is flowing. So that reactive impedance will be given by X12 and sine of delta 1 minus delta 2. Okay, so this is the active power flow equation, and reactive power flow equation will be given by Q1, that equals to V1 V2 by X12 cos of delta 1 minus delta 2 minus V2 by V1. So delta 1 and delta 2. So these are our phase angles. These are our electrical angles that actually a voltage is measured. Electrical angles. Okay. So when active power flow is controlled by control of voltage, automatically reactive power also changes. So in the previous two transformers, we were used to control the reactive power directly by controlling the voltage, but here we are controlling the phase shifting transformers or controlling the active power flow. So whenever the active power flow is controlled, automatically the reactive power flow, which is just like a coin set, just like a two faces of a coin. So active power, reactive power. Without reactive power, there will be no active power. So normally the power that we are using in our day-to-day life is our active power. So in order to use that active power, we need reactive power as a strength to our active power. So by controlling the active power, we can control the reactive power that is flowing into our circuit. And phase shifting transformers, so these changes the active power flow by changing the electrical angle delta. So this is the phase shifting transformer. So this is our phase shifting transformer. These are our phases R, Y, B. Okay. So here what happens? So here we are controlling the active power flow by controlling the voltage of the reactive power. Okay. So phase shifting transformers, these changes the active power flow by changing the electrical angle delta. Electrical angle delta. So a simple phase shifter is shown here. So this is a single phase of a phase shifter transformer. So here what happens? A voltage is injected in series with the line voltage. So these are our lines, R line, Y line, B line. So here a voltage is injected in series with the line. So for consideration now, just take it as VYB. So I am just taking a phase between Y and B. So here VYB and VYB dash. So this is our phase shifting transformer. So which is injecting the voltage into our line. Here the injection are made in the two phases also. So similarly, if you are interested to inject the voltage in R phase, you can use this configuration. And if you are interested to inject the voltage along Y and B, you can use this configuration. So like that, phase shifting transformer will be used for single phasing, that is only for R phase, and also two phases, that is Y phase and B phase. Okay, so here taps can be provided to obtain varying of the phase shifts. So in order to vary the shifts, in order to vary the phase angle between any kind of voltages, a tap will be provided. So by using these different taps, we can vary the voltage levels. And different types of phase shifting transformers are also available in our market. Okay, so now you just keep in your mind that how actually the transformers are using in order to maintain the voltage levels, in order to balance the reactive power. That's the concept here. So the concept is clear. We are using phase shifting transformers in single phase, or else we can use in both the phases. So by injecting the voltage levels or by changing the phase shifts, we can change the value of the voltage. So this is you can say, so this is a voltage along Y axis, sorry, Y phase, and this is a B phase. So this is R phase. So VR, VY, VB. So here what actually taking place in phase shifting transformer is, we are just changing the phase angle, just the slide by 10 alpha. So just take it as alpha. So this is a shifting of a phase of the angle. By just shifting of the phase of the voltage angle, we can vary the voltage levels. The varying of the voltage levels may be either you can increase the voltage levels or else you can decrease the voltage levels. So just by varying the phase angle, from VR to VR dash, okay, you are changing the voltage. So normally what happens in the, if you are considered to three phase voltage levels, the phase angle will be 120 degree, right? So ನೀವು ಏನಾದರೂ ಒಂದು ಸ್ಮಾಲ್ ಅಮೌಂಟ್ ಆಫ್ ವೋಲ್ಟೇಜ್ ಏನಾದರೂ ಫೇಸ್ ಆಂಗಲ್ ಏನಾದರೂ ಚೇಂಜ್ ಮಾಡಿದ್ರೆ ಆಟೋಮೆಟಿಕಲಿ ವೋಲ್ಟೇಜ್ ಇಸ್ ಆಲ್ಸೋ ಗೋಯಿಂಗ್ ಟು ಚೇಂಜ್. So by changing the voltage, we can vary the active power. So by varying the active power, automatically reactive power is also going to vary. Okay, so this is how transformers are using. So we will just glance. So voltage control by using transformers. So what are the different transformers that we studied? Tap changing transformer, phase shifting transformers, and booster or buck transformers. So in the tap changing transformer, what we did, we are just changed the position of the transformers. So tappings of the transformers. So just by changing the tappings of the transformers, so which are normally connected at the high voltage winding side, we changed the voltage signals. Tapping of the voltage by tapping the different positions, different tappings in the high voltage winding of the transformers, we changed the position of the voltages. So we change the levels of the voltages. So this is how the tap changing transformer works. So here we used LDC. So LDC you mention madbekagutte. So LDC is nothing but which is a voltage drop feeder along the load point. So this is the voltage feeder, voltage drop feeder along the load point. So you have to mention the construction of OLTDC with LDC, and similarly the same will be used for both the circuits, both the sides, at the sending end as well as at the receiving end, the same tap changing transformers. Okay, so TS, TR, the nominal turns ratio at the sending end, nominal turns ratio at the receiving end. So by varying the position, okay, so we have used Q is equals to T of 1 minus T into V square by X. So where if you are using the tap position T is our normal ratio of the tap position, okay, and if the T is less than 1, then Q is positive, you are sending the reactive power from sending end to receiving end, and if T is greater than 1, Q is negative, you are absorbing the reactive power from the load. So this is about tap changing transformer. And in the buck transformer or else a boost transformer, you are increasing the small nominal value of the voltage when compared to main value of the voltage. So these boost transformers and or else buck transformers will be used at the transmission line side, and by depending upon the requirement of voltage, we can boost the transformer or buck the transformer. So that is by injecting the voltages in series along the transformers. Okay, so the configurations, different configurations are the primary of the booster transformer will be connected to secondary of the regulating transformers, and the primary of the booster transformer will be connected to tertiary winding of the main transformers. So we can take one polarity and tap it, so that will be used as your booster transformer. And if you are interested to decrease the voltage levels, then change the polarity of the booster transformers from first position to second position by changing by reversing the reverse switch. Okay, then we can use that as a buck transformer, and this is the normally placing of our transformer windings, primary side of the booster transformer windings along the line. So this R1 and R2 are different relays which acts like a switches. So if you are interested to use the booster transformer along the line, then close the R2, open R1 after certain duration. The booster transformer is not required in our circuit. At that time, you can open the R2 and close the R2. So this will be automatic. So relays works automatically. Okay. And the final thing is phase shifting transformers. So we are just changing the phase angles along the lines, whether it is R phase, Y phase or B phase. So here they have shown for R phase only. You can similarly change the position of change the phase of the angle in B phase or else Y phase. So just by changing the phase of the angle, we are changing the voltage levels. So these phase shift transformers can be used for single phasing or else double phasing. If you are using into single phasing, so this will be the construction, and if you are using along the two phases, and this will be your construction. So okay, so this completes the voltage control by using transformers. So this is enough. So in the next class we will discuss about how actually the voltage is dependent with respect to our reactive power. Okay. So I was keep on telling, theoretically I was explaining how actually the reactive voltage. I was keep on telling that voltage depends upon power. Voltage depends upon the active power.